beginning of time, humans have looked to the night sky. Some just wanted to stare in awe at the beauty of the multitudes of twinkling lights. Others sought to understand the secrets those lights hid. Soon we gave the little lights in the sky names and distinctions. The first 5 planets discovered are often called the classical planets. They can be seen by the naked eye. Mercury, Venus, Mars, Jupiter, and Saturn can all be seen by the naked eye and thus have been seen by a variety of cultures worldwide. We will never know who first looked up in the sky and noticed that one reddish dot had moved slightly. If you were to ask me, I would say it was Herbert W. Planet, a 19th century British scientist who, due to an incident involving an experimental time machine, was sent back in time. He taught the very first humans the way of the universe that he himself had learned in school. Thus he created a bootstrap paradox and doomed our timeline. He met his unfortunate end at the hands of a cave woman he had tried to woo. As it turns out, British manners and courtship rules do not translate well to the caveman lifestyle. So we were left with knowledge of only 5 planets for the longest time. As time went on, other things were discovered in our solar system. Like that time Galileo looked at Saturn with his telescope and discovered it had ears and was indeed listening to us. A 6th planet wasn't discovered until 1781. In that year, Sir William Herschel first observed Uranus through a telescope. People soon realized that Uranus had a funky orbit. Whenever they look at it in the night sky, it was always a little bit off where their calculations said it should be. Thus, they realized that there should be another planet past it, one that was gravitationally affecting it. The man who in many ways spearheaded this movement was Urbain Le Verrier. Verrier was a French astronomer who in 1846 discovered Neptune using mathematical calculations and not a telescope. His calculations were quickly backed up by actual observations of Neptune in the coming days. But Neptune ended up being way too small and far away to fully account for the weirdness in Uranus' orbit. So it was concluded that there must be something even bigger or further out that was also affecting Uranus. At the time we knew of 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So the stage was set for the discovery of a 9th planet. It would take 84 years for the suspected 9th planet to be found. Let's set the stage. The year is 1930. A lot is happening around the world. Gandhi is beginning his civil disobedience campaign against the British rule. First ever FIFA World Cup was held in Uruguay. The Great Depression is in full swing and no one is happy. Betty Boop is born from the void between the stars. And of course Pluto is discovered. The discoverer was a man by the name of Clyde Tombaugh. Born in 1906, Tombaugh was an unassuming man out of Steeter, Illinois. Coming from a farming background, he never had any high hopes for attending college. Undeterred, he created a telescope for himself at the age of 20. He did this after determining that store-bought telescopes weren't all that great. He would use his telescope to view planets in his spare time. He would also sketch what he saw. He had sketches of Mars and Jupiter they sent into the Lowell Observatory in order to get some advice about them. What the advice he wanted, we don't know. What we do know is that upon seeing the sketches, the workers at the observatory, instead of sending back just advice, sent him back a job offer. He began working at the Lowell Observatory in 1929. The Lowell Observatory, located in Flagstaff, Arizona, was built by Percival Lowell with the express purpose of finding the 9th planet. Lowell was a wealthy businessman with a passion for astronomy. The observatory was built in 1894 and continued its mission of finding a 9th planet long after Lowell's death in 1916. Tombaugh worked at the observatory for several years looking for signs of a 9th planet. In that time he discovered more than just Pluto. In fact, he spotted such classics as 3824 Brindali, 4510 Shauna, 3775 Ellenbeth, 3754 Kathleen, 3310 Patsy, 2941 Alden, 3583 Burdett, 4755 Nikki, 5701 Baltuck, 6618 Jen Simmons, 7101 Hartinina, 7155 McKellar, and of course who could forget 87781931 TD to the... That's not the third power, that's a small 3, I don't know. And of course 2839 Annette. Annette is special because it has a 3D model that you can spin on some websites. Outside of Annette having a rough 3D model created from a light curve, none of these have pictures or barely any information about them. And of course they're all asteroids. With so many bangers, it's hard to imagine how Tombaugh could pass them, but of course he did, being the Sigma male he was. February 18th, 1930, the impossible happened. When comparing 2 photographic plates taken between January 23rd and January 29th, he saw something. A tiny dot had moved, a dot that would later be named Pluto. But how was it named? Well, that is one of the most unique parts of the story. Upon the announcement of discovery of a potential new planet, thousands of letters and telegrams flooded into Lowell Observatory with suggestions for the name of said planet. The telegram with the name Pluto came from the most unexpected of sources, an 11-year-old girl named Vetinia Burney. The telegram even says it should be named after Pluto, the god of the underworld, because it is a dark and gloomy planet. The name seemed to fit perfectly. It was a Greek god. It was named after the god of the underworld, which is fitting considering how far away Pluto was from the sun, and the first two letters in Pluto are P and L, which are the initials of Percival Lowell, the man who built the observatory was discovered in. It was the perfect name. After the initial discovery of Pluto, not much happened regarding it for a very long time. It was just at the time we discovered it, we really didn't have the technology to do much. Pluto was so small and so far away that the telescopes at the time couldn't gain any detail from looking at it. All we could really do was figure out its orbit and general size and diameter through math. As we studied it more, one thing became abundantly clear. Pluto was small. Like really, really small. So small that many moons in the solar system were much bigger than it. Another weird thing was how close Pluto's orbit took it to Neptune. Pluto's orbit is very elliptical, which means that it's perihelion. It's actually the 8th planet in the solar system instead of the 9th because it gets closer to the sun than Neptune. Two facts led to one reoccurring conjecture about Pluto. Perhaps Pluto wasn't originally a planet, but a stray moon of Neptune. The first person to speculate on this was R.A. Littman in 1936. Littman pointed out the similarities in the size of both Pluto and Triton, one of Neptune's moons. He said that perhaps in the past Pluto and Triton collided or got too close to each other, and Pluto was thrown out of the system, while Triton's orbit due to the collision was reversed. That would explain why Pluto was so close to the Neptune system so small, and also would explain why Triton's orbit was in retrograde compared to the rest of the system. Almost 20 years later, an astronomer by the name of Gerald Kuiper, the same Kuiper who is the namesake of the Kuiper Belt, said that Pluto was also a moon of Neptune. His theory differs in the sense that instead of Pluto and Triton colliding, he thinks they might have both been part of some protoplanet or larger moon that at some point dissolved. The evaporation of this planet would have thrown Pluto into its own orbit. With that, nothing much happened in regards to Pluto until October 18, 1977. In 1977, a man named James Christie was combing through photographic slides of Pluto at the United States Naval Observatory. His objective was to better refine our knowledge of Pluto's orbit. But suddenly he notices something. On one of the slides, Pluto has a noticeable bulge. The slide with the bulge had previously been marked as poor. It was assumed that Pluto's weird shape in the photo was due to a photographic error. Christie noticed that despite the bulge on Pluto, everything else in the photo was accurate. If only Pluto looked weird in the photo, then it couldn't be because of an overall issue with the photo. Christie had experience fighting double stars, so he knew what to look for when two objects overlapped closely in a picture. He came to the conclusion that the object must be some kind of moon or maybe even a second planet that orbits with Pluto. He gave it the name of Charon, which stuck unofficially for almost 10 years until it was made official. The funny thing is, Charon is a mythological figure tied to Pluto, but that's not why he picked it. He picked it because it sounded like his life's nickname, Char. The connection to mythology was purely coincidental. Charon was much like Pluto in the sense that its size made it stand out compared to other objects in the solar system. Charon is weirdly big compared to Pluto. So big, in fact, that Charon doesn't orbit Pluto, but they both orbit around a barycenter outside of Pluto. Because of this, people at the time started to suggest that perhaps Pluto and Charon were a double planet. Instead of Charon being a moon, both were planets that they orbited each other. The idea of Pluto and Charon being two planets is unprecedented in our solar system. There's no other example besides maybe the Earth and the Moon in a few million years of a planet and a moon where their barycenter is outside. To this day, people still discuss Pluto and Chiron's relationship, but now around the context of are they dual dwarf planets instead of planets. After the discovery of Chiron, nothing really happened regarding Pluto for a long time. It was much like earlier in the video where I discussed we just didn't really have the technology. Pluto's so far away and so small, even today, we can't really look at it with a telescope and gather much. A lot did change though in 1990 when the Hubble Space Telescope launched. Its launch brought about a new age of astronomy. Suddenly we could view objects previously unknown and unheard of. We could view into the vastness of the cosmos and find things that we never could have imagined. But even the might of the Hubble Space Telescope couldn't really gain much info about Pluto. Using an exposure time of almost a week, Hubble stared at Pluto, slowly gaining a picture of its surface. The picture, as you can see right here, isn't amazing. It can barely show the color and contrast of the surface, but it was a start. It was something we had never done before. We could now see at least basic surface features. This happened in 1996. For a long time it'd be the best picture of the far-flung world. The coolest part about the picture has to be the fact that if you compare it to the modern ones, you can actually tell where certain surface features are. It's hard to tell in the original, but when you compare it to the new pictures, you can clearly tell where Pluto's heart is. Clyde Tombaugh died in 1997, just a year after the Hubble telescope pictures were taken. He lived to see a picture of Pluto's surface, albeit a very, very basic one. His remains were cremated, and they will become important later in the story. After this, not much happened until the 2000s, where things quickly escalate from 0 to 100. You're probably all waiting for the big events that happened in 2006 and 2015, but there's a lot in between, like a lot. Starting in the early 90s, there were rumblings of a potential unmanned spacecraft mission to Pluto. Several projects were proposed and then ultimately rejected before one was settled on. Some examples of this were the Mariner Mark II, which was an idea for a spacecraft that would visit several planets along with Pluto, or perhaps to initially go to Pluto and then use that to go to several Kuiper Belt objects outside of it. The idea of going to Pluto then exploring other Kuiper Belt objects would later be at least partially reused for New Horizons. The next idea was Pluto 350. Pluto 350 in a lot of ways was the antithesis of Mariner Mark II. It was small, cheap, and basically was designed to go to Pluto and then be done with it. No extra missions, no extra bells and whistles. It had one goal, and it would do it mediocrely at best. The Mariner Mark II was shot down for being too expensive and big, so the Pluto 350 was little more than a massive backpedal by the people who wanted a Pluto probe. These people actually had a name. They were called the Pluto Underground. They named themselves after the Mars Underground, which was a similar contemporary group seeking to restart NASA missions to Mars after almost 21 years. The Pluto Underground had the express purpose of getting a mission to Pluto no matter what the cost. They were the ones responsible for the previous two proposals. The problem was, there just wasn't that big of a push to go to Pluto. It's kind of always sat in this very sad middle-of-the-road position when it comes to exploration. Everyone wanted to send a probe to it, but the problem was there were so many places that could better receive funding. For instance, both Voyager 1 and 2 had the opportunities to go to Pluto, but at the time scientists decided it would be better if they explored different objects. Voyager 1 could have gone to Pluto after visiting Saturn, but it was decided instead that it would go to Saturn's moon Titan, which made going to Pluto impossible. Voyager 2 could have gone to Pluto, but it was a secondary objective. Basically, the thought was after it's gone to all of its main targets, if Pluto's in range, we'll go there. Unfortunately, after doing all of its tasks, Pluto was not in range of Voyager 2, so Voyager 2 was just sent careening out into nothingness. After then, that was the same thought process for other probes. You could send something to Pluto, sure, but Pluto's just a small rock out in the middle of nowhere. Why not send something to Europa, one of the best candidates for life, or Titan, or another thing to Venus, or something to Mars? Pluto is small and very far away. Sending something to it is very expensive compared to just sending another probe to Mars, and moreover, the amount of scientific knowledge gained from visiting Pluto was in comparison to what would be gained from going to Mars or Venus. It was an unfortunate situation. No one didn't want Pluto to be visited, but you can't justify it if you're looking at it from a budget standpoint. Why go to Pluto when there are so many other places you can get to cheaper and with more opportunities for breakthroughs to happen? What Pluto exploration needed was a big push, something that got the public's eye on it. Because if you couldn't justify from a scientific or budget standpoint, you could definitely justify a mission if that's what the public wanted. That push came in 1991. In that year, the US Postal Service released a new series of stamps. The series was about every single planet in the moon. It had an accurate picture of each planet and then a probe that was sent to it. Every planet had its accurate picture and its probe, except for Pluto. Pluto was just kind of a grayish dot, and underneath it said, "Not yet explored." The one stamp, which had a picture that was little more than an artist's interpretation of what Pluto could look like, and no probe to be found. Just 3 infamous words. It was as if the US Postal Service had directly issued a challenge to NASA. That was it. That was the impetus that so many people were needed. The public's awareness of the unexploredness of Pluto had reached an all-time high, and many scientists, especially those who were in the Pluto Underground, or ones who just wanted to see Pluto explored, saw this as a personal challenge. Those 3 famous words became a slogan. They became a symbol. They were something that people would use to justify going to Pluto. A scientist even called Clyde Tombaugh and asked him for permission to explore his planet, and Tombaugh replied he was welcome to it, but would be one long cold trip. All of this led to a new project, one called the Pluto Express. The Pluto Express was simple. It was designed that way intentionally. It was just going to go to Pluto. Much like the ill-fated Pluto 350, it was going to be small and have the bare minimum amount of instruments. It had one job, and it was going to do that one job. Its smallness and cheapness would actually allow it to be launched faster, because if it was smaller, it might be able to load into a rocket and gain more velocity from it. The problem was, the cost just kept ballooning. As with anything that NASA seems to do nowadays, there were delays and setbacks, and it just kept getting more and more expensive. Soon the total cost reached $1 billion, way past the original intended plan. At that time, though, the rapid discovery of Kuiper Belt objects was in full swing, so the Pluto Express was repurposed into the Pluto Kuiper Express, deciding to make it a bigger, more all-encompassing mission that would visit Pluto first and then visit several other objects along the way, similar to how Voyager had gone through all of the planets. But after that, the project just continued to languish and increase in budget until ultimately the project was put as low priority, which cut most of its budget, and then canned. The project was scrapped in 2001, but it would only take 2 years until a new project rose from its ashes, New Horizons. Due to increasing political pressure, it was finally decided that they would get a probe to Pluto no matter what the cost. So, 2003, New Horizons was greenlit, with a launch date set for 2006. Between 2003 and 6, not much happened regarding Pluto, except 2 pretty small discoveries. Hubble took a picture of the Pluto system one day, and when it was being overviewed, astronomers at NASA saw 2 little dots near it. Immediately they realized that those 2 dots were so close to the Pluto system that they must be new moons. These new moons were pretty small, in the tens of kilometers small, and they both received a name. The one closest to Pluto was named Nyx, after the goddess of darkness, and the one further away was named Hydra, after the multi-headed serpent. Remember I said earlier that there were Kuiper Belt objects being discovered left and right? Well, they discovered a few that were similar in size to Pluto. 2 in particular, Eris and Sedna, were very close in size to it, and also were in the same general area. So that rose a question. If we keep finding objects like this, we have to either make them planets, or if we say they aren't planets, then we have to take Pluto off the planets. Now this normally wouldn't be a problem, except they were finding what would be defined as planets left and right. We were suddenly going from 9 planets to 12, then maybe 15, then 200. We had to figure out what a planet was, or risk having so many planets that the meaning meant nothing anymore. So the International Astronomical Union had a meeting, and decided they would figure out what a planet really was. After much deliberation, they settled on 3 basic rules. A planet must orbit the sun. It must have enough gravity that it's been turned into a sphere, and it needs to have cleared out its general area of asteroids and debris and the like. The 3 of those make sense. All the planets we know of orbit the sun, they're all round, and you don't see a bunch of random asteroids floating around the Earth. Pluto fits 2 of those, but the problem is it's in the Kuiper Belt. It just doesn't have the size or gravity to clear out its general area of debris. So it wasn't really a planet. So what do you define Pluto and all those new things they were finding, like Eris and Sedna? They settled on a new definition: dwarf planet. Dwarf planets, as the name suggests, are basically just smaller planets. They're not big enough to do all the things normal planets can, but they're planets in their own right, if that makes sense. The great irony of this was several months earlier, New Horizons finally launched. It launched when Pluto was still a planet, and within a year of its mission, it was now going towards something that wasn't a planet anymore. These new IAU definitions had one major gap in them. They didn't allow for double planets or double dwarf planets. They say that an object has to orbit the sun, but if there are 2 planets of similar mass in a double planet system, they technically orbit each other and the sun simultaneously. Same with double dwarf planets. The reason why this is important is because to this day, the issue of Pluto and Charon's relationship persists. Many people still say, even if Pluto is now a dwarf planet, then Pluto and Charon are now a double dwarf planet. Because like I said before, Charon doesn't orbit Pluto, they orbit each other. This issue has actually been acknowledged by the IAU. They've said that in the future they will further refine the rules and potentially make Charon a dwarf planet in its own right. 2006 reclassification of Pluto has to be the most infamous thing on this list. To this day, you have lots of people in the public saying that it shouldn't have happened and that Pluto should still be a planet. Many just say that because they don't understand the scientific reasons why. There are also many scientists who say Pluto should still be a planet for cultural reasons. They argue that the classical planets were always planets and cultures, and that Pluto, ever since been discovered, has also had that cultural aspect. They argue that a planet might not be so much a type of astrological body, but a type of object that has significance to human culture that orbits the sun. In 2010, NASA released new Hubble photos of Pluto. These Plutos were taken in 2003 and 4. They're a big improvement over the 1990 ones, but still, even with all the improvements Hubble has gotten over the years, still are a little more than a blurry mess. The big difference is this time we can actually make out some color from the surface. What's more, if you compare these to the modern pictures or even the old ones, you can still make out the same discernible features among all three. In 2011, the new moon Cerberus was discovered around Pluto, and in 2012, the new moon Styx was discovered. Both discovered the same as the last two through Hubble pictures. Both are also, just like the last two, super small. In fact, it's incorrect even to call them moons of Pluto, since, as I've said before, Pluto and Charon orbit each other. So the other four are actually the moons of Pluto and Charon. After 2012, nothing happened for 3 years. For those 3 years, it was 2015. And arguably, the most significant thing since Pluto's discovery has happened. New Horizons has arrived, and it is sending back pictures at an astonishing rate. We finally got to see it, or at least properly see it. An ancient world of ice and snow, with a lower half that looks almost blood-stained. Craters and mountains dart its surface, and the contrast between all of its bits are truly astonishing. But the most prominent feature of all is a single plateau. A plateau which looks suspiciously like a heart. That's really where the story ends. New Horizon takes the hundreds of pictures, and they're all a sight to behold. And they're way outside the scope of this video to fully cover. But there's one final thing to cover. Remember how I said earlier that Tomba's ashes would become important again in the future? That's because about an ounce of them put on the New Horizons spacecraft, along with one of the infamous, not yet explored Pluto dams. Both of them were sent on their journey to Pluto with the spacecraft. And both, in their way, got to see it. Tomba, after almost 100 years, finally got to visit the world, which he'll be known by for the rest of history. And in a fitting memorial, the big heart on Pluto, the IAU officially named it after him, the Tomba Regio. I don't know what the Regio part stands for, but that heart will forever symbolize his discovery.